My dear friends, welcome back to Bee Spice. So this is Bala with you. In this session, we'll continue with the control valve design and specification, wherein the focus is more on face-to-face and end connection. Okay. So face-to-face in the sense, what type of phase, whether it's a flat phase, right phase, then ring type joint phase, and what are all the criteria involved, and also the end connections, and of course a bit of standards. All these we are going to cover. Okay, friends. So let's get started with the standard valve face-to-face dimension. Okay. So what are all the standards? And see, basically we know several standards organization issue and maintain standards for face-to-face and end-to-end dimension for control valve, right? This we know. So face-to-face dimension are listed for flange valve bodies, while end-to-end dimensions are given for welded in and screwed in connection. So that is the point. Just listen, friends. Face-to-face dimensions are listed for flanged valve bodies. You got it? While end-to-end dimensions are given for welded in and screwed in connection. Just remember that. Okay. What are all the standards? One is the ISA, Instrument Society of America, ANSI, American National Standard Institute, then MSS, Manufacturer Standardization Society of the Valves and Fittings Industry, then DIN, Deutsche Industry Norm, West German National Standard Organization, then IEC, International Electrotechnical Commission, then APA, American Petroleum Institute. So these are the standards. Let's see one by one what it says. Okay, ISA, Instrument Society of America. Okay, so ISA standard S75.03 specifies face-to-face dimension for flanged globe style valves through class ANSI class 600 up to 600. Okay, remember friends, ISA standard S75.03 specified face-to-face dimension for flange globe style valves through ANSI class 600. Okay, then we have S75.16. What it does, it lists dimension for globe valve in ANSI classes 900 through 2500. You got it, friends. So S75.03, of course, for flange and globe valve, ANSI class up to 600. But the 7516 actually for globe valves from class 900 to 2500. Okay. Then 75.04 specifies face-to-face dimension for many flangeless and rotary shaft valves. So just remember this. This is very important actually. Okay. All these are interview questions, friends. Yes, 75.12 list end-to-end dimension for socket weld and screwed in connection. See, 75.04 for flangeless and rotary shaft. 75.12 for socket weld and screwed in connection. You got it? Yes. 75.15 list end-to-end connection for ANSI class 150 through class 2500 butt weld. That is a point. 75.15 butt weld. Then see, we know ISO standards are the most popular standard for control valves. Okay, friends? You got it? Right. So this is about the ISA. Now we'll go to the ANSI, American National Standard Institute. Okay. So in the past, ANSI B16.10 was a primary standard for face-to-face and end-to-end dimension for all control valve and connection. This we know. But however, the ANSI has relinquished the responsibility for this dimension to ISA. Okay. You got it? Yes. So fewer and fewer references to ANSI B16.10 should be observed that now that the transfer of dimension standard to the ISA is complete. Almost done. Almost done. All now we need to refer to ISA. Okay, friends? So that's a piece of information I want to inform you. Okay. Then MSS, Manufacturer Standardization Society of Valves and Fittings Industry Inc. Okay. See here, interesting things. MSS SP67 lists face-to-face dimension for conventional butterfly valve construction, while MSS SP68 lists face-to-face dimension for high-performance butterfly construction. So that is the point. Okay. SP67 conventional. SP68 what? High performance butterfly valves. That's it. Now DIN, Dutch Industry Normal. So this is a West German National Standard Organization. So it's basically the didn't face-to-face dimensions are unique, friends. I think we'll stop with that. Huh? We'll stop with that. Okay. Let us not go into much delve into that. Okay. So IEC, International Electrotechnical Commission. Okay. See, basically IEC standard EC 53431 is taken directly from ISA 75.03. That's a point. Okay. Then IEC standard EC 53432 is taken directly from ISA 75.04. These things also, this relevance also we should know. Okay, got it, friends? Good to go. Then one more is the API. So American Petroleum Institute. Basically, this API standard relate primarily to pipeline equipment other than control valves. Okay, friends, right. So, however, the face-to-face dimension that are included in API 609 are identical to the dimension in MSSSP what 68. So that is the add-on information. Friends, I have given this just to awareness, friends, for your awareness. You should know all these things are there. Okay, that is a point. Now we'll get on with the real thing. Okay, so as we know, the body end connection and rating shall be in accordance with the requirements of the piping class, right? Hope you agree, right? I will show you the material specification for the piping class also, the look and feel, okay? Make you more comfortable. Of course, the experienced engineers know this is for, again, the intermediates and the freshers, okay? The flange gasket contact surface finish and flange connection shall be in accordance with the ASME B16.5 or ASME B16.47 pipe flanges and pipe fittings. Basically, some are applicable for B16.5 and some are actually B16.47. I'll show you the piping class, you understand better. Okay, friends? So the point is the flange gasket, contact surface finish and flange connection. Surface finisher. I will tell you what is that surface, all these, okay? And flange connection shall be in accordance with ASME B16.5 and ASME B16.47 some cases. Okay. For control valve flange face-to-face selection, three types of flange facing shall be considered. These are the common actually, but there are few more. Okay. One is a raised facer. We call it as a RF. Second is a flat facer. We call it as a FF. Then the third one is a ring type joint RTJ. Okay. So what is this? This, all these we'll see. Don't worry. Okay. Then in addition to that, friend, this is for the flange, right? Flange. Okay. Addition to that, there is others also there related to flange. One is a separable flange. What is the separable flange? All we will see. Then wafer style. Okay. That also we'll see. Then apart from this flange shape, there is also, the welded connection and threaded connection. All these we will see. Okay. So these are the flange, right face, flat face, ring type joint, separable flange, wafer style. Apart from that, the connection, welded connection and threaded connection also we'll see. I'm mixing it actually. Okay. So piping material specification. This is the look and feel, friends. For example, this is my line class A1, A1. So if you remember our previous videos on the P&AD, how to read a P&AD, right? There is a line class, right? Yes. If the line class says A1, A1, how to read, how to interpret? Yes, you need to refer this piping material class. So A1, A1 is a line class. Oh, you have to see here, flange. Yeah, this is my flange. You see size. It is applicable from 3 to 6. So this is the class 150. What is the end? Rise space. See the material. ASTM A105, 125, 250. Roughness average, right? Yes. And ASME B16.5. Got it, friends? And this is the material code. Okay. And you can see here one more example. You see here. This one for 2-inch. Schedule for 80 excess CL, this one 300, then rise face and ASTM A105 and this roughness average, and this is your ASME B16.5, and here you can see B16.47. This is how we need to refer this piping material class and select our flange. Okay, friends, you got it right? Okay, good to go. So this one is to support this statement. The body in connection and rating shall be in accordance with the requirements of the piping class. You got it? Okay, hope it is clear. No problem. Yeah. Anything, any question, please feel free, friends. Whether you are a subscriber or a member or even not a subscriber, you can share with me any questions. You can write to me. Okay, right. So now we'll see rice phase plant, friends, or F. This is the look and feel. Can you see here? This one, raised phase, right? Yes. So this is the diagrammatic representation. You see here and see the bulb. I mean this rice, right? Yes, yes, like this, right? So inside the gasket. Okay, friends, right? So the rice phase branch is the most common end connection. Okay, this we all know. These branches have a circular, okay, rice phase, circular rice phase with concentric circular grooves for a good gasket sealing and resistant to gasket blowout. So that is the beauty. Okay. So the line gasket only covers the rise face portion of the flange. The line gasket only covers the rise face of the flange. Okay. As the line bolting is tightened, when we tighten this line bolting, high stresses are produced at the perimeter of the each flange. Okay. And therefore, rise face flanges are available only for strong ductile, non-brittle materials such as carbon steel and stainless steel. That is the point. The point is, as the line bolting is tightened here, high stress are produced at the perimeter of the each flange, right? Okay. So therefore, rise phase flanges are available only for strong ductile, non-brittle materials such as carbon steel and stainless steel. You got it, friends? Okay. So rise flag phase shall be used for medium pressure applications or valves with a class rating of 300 and 600. Up to 600 we can go for this rise phase. Okay. In some cases they are going also 900 also. But for 900 we have some other types also. That is why I just limit this to 600. But it's not necessary that we should stop. We can also go for 900. Okay. Right. So that is the point, friends. So yes, now few more interesting actually. Friends, the diameter and height are in ASME B 16.5 defined by the pressure class and the diameter. Okay. See, whatever the diameter, and height, whatever is mentioned in this ASME B 16.5 are basically defined or derived by the pressure class and the diameter. Okay. So now you see, pressure rating of the flange determines the height of the rise face. That is the point. Pressure rating of the flange determines the height of the raised face. That is the point. Okay. So typical flange face finish for ASME B 16.5 RF is from 125 to 250 micro inch or roughness average or 3 to 6 micrometer roughness average. This is what I was highlighting in the piping class. You remember? 125 to 250. Yes, that is the thing. Okay. Another important point is in pressure classes 150 and 300, the height of the rise phase is approximately 1.5 mm. You can see here, friends. Actually 1.6, 1.6 actually, yeah. So approximately 1.6 mm. In the pressure rating of class 150 and 300, this, what do you call it? The rise phase, right? So this is the one. You can see here, this portion, this bottom, right? So it is basically 1.6 mm. Okay. So that is 1 by 16 inch. Okay. In a pressure classes of a rating of 400 and 600, the height of the rise phase is approximately 6.4 mm. 6.4 mm. Yeah, you can see here this one, 6.4 mm. So it is 3.5, approximately 1/4 inch. Okay. So that is the point we should remember, friends. Okay. So now we are done with the rise phase. Now we'll go to the flat phase. Okay, this is the flat face. See, you don't have this rise, right? Yes. You can see here. Here there is no projection, right? Yes. This is the flat face. So this one used for low pressure application of a valve with a low class rating, 150 pounds. As a general practice, minimum flange rating for the control valve body should be ANSI 300 pounds. That is the thing. In fact, big petrochemical refineries like, Shell, Exxon, they all follow this. In fact, my ex company, the Woman Refinery, actually I follow this ANSI 300 pounds only, minimum for control oil especially. Okay. Then Flat face flange allows a full face contact with the gasket clamp between the flanges, right? So it's basically full face contact. So full face contact has the advantage of minimizing the flange stresses, right? Yes, that are caused by the force of the line bolting. Because here it's already full face, right? So you will not have this, stress. So flat face flanges are common with cast iron bodies because there is no much of forces actually, which are brittle and would crack if rice flakes are used. Okay, flat face basically with the cast iron bodies. Okay, but whereas in the rice phase we have to go with what? Carbon steel and all, right? Yes. So flat faces are also common with brass and aluminum bodies, which are soft and would bend if rice flanges are used. So the point is we should not use this aluminum, brass, all these for this rice face. Okay. So I hope this is clear, friends. The flat face. Okay. Now, another interesting ring type joint, we call it as a RTJ. Okay, so ring type joint RTJ shall be used for high pressure application of a valves with the rating of class of 900 pounds and above. So, matching grooves in the body and pipe flanges retain a solid metal ring. You can see here this matching grooves in the body and the pipe flanges, you see the pipe flanges retain a solid metal ring. You can see here, right? Yes. So as the lining, okay, sorry, not the ring. As the line bolting is tightened, the ring deforms and conforms to the grooves. That's the beauty. As the line bolting is tightened, the ring deforms and conforms to the grooves. It may be hard to visualize, but you just get the concept, friends. Okay, this seal is a this seal is pressure assisted because as the pressure increases, the ring pushes against the groove and make the seal tighter. Okay, this seal is a pressure assisted because as the pressure increases, the ring right pushes against the groove and they make the seal tighter. Okay, that is about the ring type joint. Then separable flange. One more is there. Separable flange is another variation of the rice face flange. In this construction, the flange is manufactured independently of the valve body. That is the different. This is your flange, right? This is your split ring and this is your body. The flange is independently manufactured. Okay, that is the point. Split rings are required to secure the flange. This one, the split ring, right? So to secure the flange, secure this flange to the body and transmit the bolting force to the gasket and the mating connection. So that is the point. Again, this is hard to visualize, but just get the concept. Okay. So when an expensive body, the point this is important. When an expensive body material is specified, for example, they are looking for some, SS kind of thing, then separable flanges may result in some economy, meaning because the flange can be made of more economical materials such as carbon steel. Your body can be SS, but the flange can be like this. So I don't see actually anything like that, but this is one of the options available. If it goes well with the process medium and the rated pressure, all this temperature, all these, just this is just I want to share as info, friends. Okay, some companies prefer separable flanges because a standing inventory of the control valves can be adapted to several different piping configuration just by simply installing the appropriate flange. So that is the point. One way they also have the economy, and other way they can have a better inventory. Okay, so that's the thing. But to be frank, I never come across this kind of application. I mean, I personally never seen actually. Okay, but there is an option. Just remember like that. There is an option. Okay, if if necessitates this kind of a scenario. Okay, so that's a separable. Then wafer style, friends. This is the look and feel of the wafer style. See, a wafer style valve body includes a rice face contact surface in the body casting. Okay, you can see here inside. It's a rice face actually. Yeah, the face conform to standard rice face flange dimension and they include a concentric grooves. Okay, here it's actually a concentric grooves just like a standard rice face. Okay, the line bolting sandwich the wafer body and gasket between the pipe flanges. This line bolt, you can see the lengthier line bolt, right? Yes. So ball and butterfly valves are commonly available with this body style. You might have seen actually. You might have seen a plant, but especially the butterfly actually. Just visualize, just recollect. Yes. So for butterfly valve, we normally use this kind of wafer style. Okay. So with that, just remember this as a concept. Okay. Right. Then we talk about the welded in connection, friends. So you can see the typical welded in connection. Where we use this actually? See, in many high pressure and high temperature application, the valve is welded directly to the pipeline, right? Some people do actually. Yeah, especially in the power plants and all, they do actually because of the high pressure, 60 bar like that. So welded end connections are leak tight at all the pressures and temperature. Welded end connections are economical in the first case, but again, valves with welded ends are difficult to remove from the pipeline for service. That is a problem. Very, very difficult. Yeah. So maybe we have to fit and forget it, that's all. Socket weld ends are common for smaller valve. You can see the socket weld, yeah, is all actually what you call smaller valve sizes are through 2 inch. But butt weld are standard for 2.5 inch and larger butt weld. Okay, friends? Okay, you got it. This is also some info for you. Then we have also threaded connection, but I have never come across, but I want to share. Threaded connections are popular for small controller because of their economy and ease of installation. Threaded end connections are generally not available for valve bodies that are larger than 2 inches. So basically it's for less than 2 inches. That's all. So that's it, friends. I hope you got some insights on the standards involved in the face-to-face and the end connection, and also the different types of face-to-face connection, rise place, flat face, and ring type joint. All these, right? Yes. So if you find it is useful to you, just show your support, friends. Show your support by pressing the thumbs up button, and if possible become a member to support the BSpice channel initiative. And of course, if both are not possible, at least subscribe. And if that is not possible, at least watch, friends. Watch and get benefited. Okay. My intent is at least one person should get benefit from my video. That is my only intent. Thanks for watching. And yeah, see you soon with the other interesting video. Okay. Of course, there are a lot of things we have to cover in the control valve. And one side we are focusing on Centum VP, other side we are focusing on engineering, and parallelly we are also working on the control valve, so that you will not get bored. That's the intent, friend. That's why I'm mixing it. Okay. Thank you. Take care. Bye bye.